Hello everyone. We will be starting a new series wherein I will take an interview experience from lead code and try to solve all the questions that are there in that particular interview experience. We will be discussing all the follow-ups that are asked during the interview, and apart from this we will also cover some of the extra follow-ups that might be possible related to the same question. So please stay tuned to till the very end of the video. Hope you will enjoy. Let's start. So today we will be covering this interview experience of Amazon Onsite. I will link the interview experience in the descriptions below for your reference. In this specific video, we will be discussing the first question of this interview, which is this lead code 1603 and all its follow-ups. So the question is basically we have to design a parking system for a parking lot. The parking system will contain three types of cars, or basically three types of spaces for the car. Uh, One space for big car, second type of space is for medium car, and third type of space is for smaller cars. We will be given each of the availability of each of these type of spaces in the constructor of this parking system, and we need to answer queries like, given a car type, whether there is a space to park that particular car or not. So that's the simple question. So let's try to solve it with an example. So let's say there are two spaces for smaller cars, four spaces for medium car, and six spaces for larger car. And we are getting queries in this manner, like from left to right. First we will be getting, we have to place a small car, then we have to place a medium car, then again a small car, and so on. So for first query is we have to place a small car. So we will place like we can see there are two spaces. There are two spaces for small cars, so we can easily place a small car, and by placing a small car we will be occupying one small car space. So this will return true, and this will be the state of of our parking garage after this query. Then our query comes like for two, like basically park a medium car, we have four spaces, so it will be parked, return true. Now we get a query for to park a small car again. We have one space, so let's park it, and it will return true. Then again we got a query for parking a small car. So we don't have any space for small car. Notice that we do have spaces in medium and large car, but we don't have spaces for small cars. So as per the initial question, we should return false. So this will return false. Similarly, this will also return false because we have no more space for small cars. For medium car, then medium car comes. So medium car we still have spaces. So we will decrement the space and return true for this case. So now we got a query for large car. We'll decrement the space, number of spaces, and return true. And these two will again be false because we don't have any spaces for small cars. So that will be the output. Like the I hope you like this is very simple question. This is very simple version of the problem wherein we just simulate whatever we have given. So the code for this is also very simple. Let's quickly iterate over it. So we take a three variables: big space, medium space, and small space, which contains the big, small, and medium cars. And if our car type is big, we will check whether we have big spaces type available to us or not. If not, return false. Otherwise, decrement the space and return true. Similar case for small and medium cars. So that is one solution. Now let's look at some of the follow-ups. So one follow-up that was asked during the interview was uh, that we can park two small we can park one medium car in or basically in one medium space we can park two small car. Similarly, one big car can be parked in four medium spaces, four smaller spaces. So this is the follow-up question to the previous question that we just solved. Now the problem becomes interesting. So if you remember, previously we do have spaces for medium and small, medium and large cars, but we will not be able to we are not be able to park smaller cars. But now with this constraint, we will be able to do so. So problem now becomes a little bit interesting. Now, before solving the question itself, uh, it is always wiser to ask some clarifying questions if the question is not clear. So there are a lot of ambiguity in this question still. Like after this statement, there are a lot of ambiguities in the question. So I will encourage you to pause the video for a minute or so and think about all the possible ambiguities in the question. So we have like this four ambiguities to be very specific. So pause the video and try to think. So let's discuss. So for the first is whether the reverse is also true or not. So basically, we have been given that we can two small can be parked in one medium. So whether one medium can also be parked in two small or not. So whether this is also true or not. So that is one question, like that is not clarified here. Similarly, we have been given that one big car can be parked in four smaller spaces. So whether the reverse is also true, like can we park four smaller cars in one big space or not? So this is the first question that you should ask after like this question. Like this is one ambiguity in the question. So for the purpose of this question, let's assume the answer for both of them is yes. So the reverse is true, and so that it means we can park one medium car in two smaller space, as well as we can park two smaller cars in one medium space. So let's move to the second. Let's move to the second question that we can ask here. So the second question basically is the property associative. So we have been given that two small like uh, one medium car, one medium space can hold two smaller cars. So one medium space can hold two smaller cars. Similarly, we have been given that one bigger space can hold four smaller cars. So does it also means that one bigger space holds two medium cars or not? So basically, we have been given that if there is a medium space, uh, two smaller cars can be parked here. Similarly, if there is a large space, four smaller cars can be parked here. Okay. Now, given these two scenarios, we could in like if it is associative, we could infer that one large is equals to two medium, right? So whether that is true or not. Now let's assume for this question that it is also true. Okay, so it like the all the properties that we have been given is associative. Basically we can park like this statement in turn also mean that we can park two medium cars in one bigger space. So now let's move on to the next ambiguity that we have. uh, so what if there is one possible option? So let's say you have zero medium cars. Okay, now there's a request come to park a medium car. Okay, now how, like there are two possible cases. Either you can use these two small spaces to park a medium car, or you can use one large space, divide into two medium space and park one medium car there. So that's the two possibilities. So which one should be true? So for the purpose of this question, let's assume that we will first, like if there is a situation like this, let's say they like the same situation wherein we have to we have no more cars of the same space available. We will first try to fit the request with the smaller cars, and if that is also not possible, then we will go for larger spaces. So we will not be using larger spaces for smaller type of, like, we will try to avoid large spaces for smaller type of cars. So that will be the, let's say, the answer for this particular question. Now there is one more ambiguity that is still left in the question. Let's try to discuss that. So is it allowed to use different type of spaces for a single car? So basically, let's say uh, there is a scenario wherein we have zero large space, we have we have one medium space, and we have two smaller space. Okay, now we got a request to park a large car. Okay, now because there is no large space, and large cars, if you remember, is equals to four smaller cars. So what we could have done is, and also like one medium car is also equals to two smaller cars. Okay, so basically we could, what we can done is, we can combine these two space and park this larger car. So whether this is allowed or not, whether we can merge two type of spaces for a single type of request or not. So for the purpose of this question, let's assume that uh, it is not possible. Okay, but it will be a good exercise for you to try out after we have solved the entire question. With, like, if the answer for this is yes, what would be the possible solution? So for now, let's assume that it is no. So basically, what we have done is we have asked all these four questions and we got all these four answers with you, with us. So the first question was whether the reverse is true or not. So this one we got answer yes from the interviewer. Whether the property is associative, we got answer yes. What if there are more than one possible options? We have discussed. We will try to allocate with the same type of space. If it is not possible, we will try to allocate with smaller type of space. If that is even not possible, we will try to allocate with bigger type of space. And whether it is allowed to use different type of spaces for a single car, currently the answer is no. But yes, as I told, you can uh, try it with this answer as yes as well. So let's now try to solve this like with an example. So let's say we got a request to park a small car. So to park a small car, we have two small spaces. So we will first we will reduce the small space by one, and this will give us true. Now the first second is we got a request to park a medium car. Now for medium car, we have a space, so we will just reduce the number of space here and park this car, and this will be true. Now let's say we got a request to park the third, like, again the smaller car. So we have smaller car, reduce it by one, return true again. Now let's say we got a request to again park a smaller car. So again we can see we don't have smaller car space, so that then we will follow the second rule. Basically we'll try to allocate next available smaller space. So it is already smaller, we don't have any smaller space after it, so we'll again follow the next rule, that we will then try to allocate the next bigger space. So next bigger is medium, so we will use this medium car, like we will reduce this medium slot by one. And if you remember, one medium slot equals to two smaller slot, so this will give us an additional of two space here. And then we will use one of this space to park this car, and we will left with one smaller space. Now again a request come for parking a smaller car. This time we do have a smaller space, so we will just use that and return true. Again a request come for parking a medium car. We have a medium space, so we'll just decrement it by one, return true. Now we got uh, a request to park a large car. We have large car, so we'll just reduce it by one, return true. We got a request to park a smaller car. So we don't have any smaller car now, so we will go with the second one. Try to allocate next available smaller. Smaller is already the smallest, so we'll go with the third rule. Try to allocate the next bigger. So basically, next bigger is medium. So we will remove medium and add two smaller space for this, and then use one of these space to park this car. So this will return true again. Now this, like the again there is a question like park this car of smaller type. We will have one space, so we'll just use this space, and it will be true. Now just for completion, let's assume that we again got a request to park a smaller car. So in that case, what we will do is uh, we will we can see that we don't have any smaller space available. We then we will see the next bigger space, medium, which is also not available. Now we will come with larger car. So one large, if you remember, is equals to two medium, right? Or four smaller basically. So what we will do, we will remove one large from here, take make it four large, and add two medium here, because one large equals to two medium, right? Now then we will follow the same module again. Uh, we remove one medium from here and add two smaller space here. Given this, we can then we can then use one of these to park the car, and one we will be remaining with one smaller space, and we will return true for this. So hope this approach is clear. The implementation will be very similar to the previous one, just a few if else conditions would be there. Now let's make the problem a little bit more interesting. Uh, let's say instead of these three types of car, we have uh, X types of car. So basically, currently it shows only these three types of car. So let's say there is also a fourth type, or let's say there is also a fifth type, and so on and so forth. Okay, so we have totally X types of car, and we will be given the same data like the availability of each type of space, and we will be asked the same kind of question, basically given a type of car whether it can be parked or not. So the solution for this would be very similar to what we have discussed. It's just that number of levels are more in this case. So let's look at the implementation for this X types of car instead of looking at the implementation for this three fixed set of these three types of car. So the implementation would look something like this. We have these spaces, okay, and this spaces denotes the number of available spaces for each type of car. So we will just start from the biggest to the smallest. So currently we have only three type of cars, so that therefore there are three spaces: big, medium, and small. If there are more types of car, we'll just keep on appending this to the spaces array. Now once we have spaces array, when we get a request, let's say the car type, so the car type would be one of these integers like 1 2 3 4 5 or something like that. So as we have discussed, like we will first try to allocate with the corresponding space. So we will, like, currently one space is required for the car, so we will first try to allocate with this car type itself. If there are spaces, then we will just reduce the space and return true. But if that's not true, the next is we will try next to allocate the next available smaller type. So like that's what we are doing. Like the smaller type is, so basically the smaller type is going upwards. So we will, from car type, we will go to car type plus one. So notice that when we go to car type plus one, we will be requiring twice the number of spaces. So for example, if let's say I want to fit one medium car. Let's say the current medium is 0, and let's say I want to fit a medium car. There is a query to fit a medium car. So one medium to fit a medium car, I will require two smaller space, right? Similarly, to fit one larger car, I will be requiring two medium space or four smaller space. So basically, as we are going deeper in the sequence, we will be requiring more, we every time we go one level, the number of required space increased by two times. So that's where after each level, like after satisfying each level, we are multiplying this required space by two. So once that is done, we will again check whether the current space is where the current space is eligible to uh, occupy this car. If it is, we will decrement the number of spaces by that and just return true. So remember that we are not combining any of the smaller cars because of this condition. Okay, so that's why we don't have any other logic here. Otherwise, if this condition is also true, then we have to implement some logic here as well. So that I will give you as an exercise. So once we have tried out all the smaller types of car, then we will go for larger type of car. So what we have to do is, like, if you remember, uh, we have to try the larger type of car one by one. So uh, let's say we have to decrement this, let's say there is no smaller car, and there is no medium car as well. So in that case, we will choose larger car. But if there are medium cars, then we will choose medium car to allocate. So basically we will choose bigger space one by one. So that's where we are going from car type -1 to the greatest car type, which is 1 in our scenario. Uh, and if there are spaces of that car type, what will happen is, let's say the number of let's say the number of smaller space is 0, and number of medium space is also 0, and let's say that there are two larger space. So what we will do is, we will remove this one larger space, convert it to two medium space, and then we will remove this one medium space and convert it to two smaller space. So basically what we are doing is, we are removing one from the largest one, and then uh, adding two to the next level, and then removing one from that level and again adding to the next level. So that's what we are doing. So similar kind of things we are doing here as well. So we first decrement that particular space, and now, like, this variable is not required. Now what we are doing is, we are incrementing the next available space by 2, because we have to decrement it again. So we increment it by 2, and then we have to decrement it by 1 again. So final output here will be 1. So we are just assigning it 1, and for the last level we will be assigning 2. So like at the last level there will be 2 increments. So that's what we have done. And once everything is done, we will again check whether we are able to, we have some space of car type. If we have, we will return true, otherwise we return false. So basically, let's say the scenario was this: we don't have large cars as well. So in that case, the number of small cars will not increment. So that's where this check will be helpful. So hope you understand the solution. If you have any doubts or suggestions, please link them in the comment below. So basically we have tried running it with the same sample, and we can see everything is returning true. But in the previous scenario, when the merging was not allowed, some of them was false. So that's it for this video. If you have any doubts, please ask them in the comment section below. And as I suggested you can try implementing the same question with this answer, with the answer of this particular question as yes. And if you find the answer, please post them in the comment section below. I will be happy to review it. So thank you.